Hey, it's Dr. J. Today we're going to cover a few loose ends from 6.2. Just a few concepts and examples that didn't quite make it on the last video. So, in particular, we're going to talk today about end behavior. Not sure if I used that term before. And then we're going to do more natural exponentials. Usually abbreviate that EXP. Okay, we might be able to kill two birds with one stone in a couple of these problems where we talk about the natural exponential. We also talk about the end behavior. So first of all, let's just talk about what end behavior is. End behavior is the behavior at the end. No, well, that's sort of what it is. The behavior of y, or f of x, as x approaches infinity or as x approaches negative infinity. And so this symbol that looks like an arrow is read as the word approaches. Or some people say goes toward. So some people say x goes toward infinity. Or x goes towards negative infinity. Okay, or you could just say goes to. Yeah. So basically, end behavior is asking a question about what's happening to the y value or what's happening to the f of x value. Remember, y and f of x mean the same thing. Okay, y is f of x. All right, let's go ahead and do one of these problems first. Then we'll get into the graphs in a minute. So, example 1. Determine the end behavior. So f of x is equal to 6 minus 2 to the x power. So we have two ends. We have the left end. That's what happens as x goes to negative infinity. That's as x is going to the left. Now, even though x is going to negative infinity, we still write the arrow going that way to the right. I guess you could be really clever and turn the arrow around so the arrow pointed to the left, but then your work wouldn't match anybody else's work. So you kind of have to follow the right-handed world that we live in. And then you have the right end where x goes to positive infinity. It's kind of like going east versus going west. So you want to say, or you want to answer the question, what happens to the value of f as x gets really far towards negative infinity or as x gets really close to positive infinity? Now, positive infinity and negative infinity, these are ideas. Yeah. They exist only in our minds. Notice on your calculator, there is no button labeled infinity on your calculator. That's because infinity is not a thing. There's no number called infinity. So what you're going to do is you're just going to use, for negative infinity, use negative 100. Or negative 1,000, or negative 10,000, etc., etc. So you need to actually pick a negative number that's far away from 0. Yeah, negative 100 would probably do just fine. But technically, you could go as far as you want. You could go to negative 1,000,000 if you want. And then for positive infinity, you cannot actually use positive infinity. So you're going to use positive 100 or positive 1,000 or positive 10,000, etc., etc. 1,000,000, 1,000,000,000, 1,000,000,000,000. You can go as large as you want for x. I'm just going to use 100. All right. I mean, if I'm going to get the same answer using 100 that I would get using 1,000 or 1,000,000 or 100,000 or 100 billion or something, I might as well just use 100. Okay. So come over here on the left side. Plug in 100, negative 100. Sorry, we're doing the left side. Plug in negative 100 into this. So you have 6 minus 2 to the negative 100, which is 6 minus 2 over 100. Sorry, 6 minus 1 over 2 to the 100. I said that wrong. Got all twisted up in my... Okay, maybe I'll remind you what f of x is. I just ran out of space here. F of x is 6 minus 2 to the x. That's what we're using. All right. So this is 6 minus, now watch this. When you do this on your calculator, sorry, I hit the wrong button. Negative 100, and then I'm going to go 2 to that power. You're going to get 0, 0, 0, 0, 0, 0, 0, 0, 1. So you're going to get 5.999999, which is basically 6. Yeah. This number is so small. In fact, some calculators, depending on what kind of calculator you have, will actually give you 0 for this value. That's not really what it is. It's just there's so many zeros that it just fills up the entire calculator screen, and you don't see anything but a bunch of zeros. My calculator gave me 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. Yeah. So that's 5.99999999. And so that tells me as x goes to negative infinity, f of x is going towards 6. Okay, this is called the horizontal asymptote. Remember, f of x is the same as y. So you just say y is equal to 6. It turns out that you're never actually going to get to 6. It's going to be 5.9, 5.99, 5.99999, 5.99999999999. It's going to go on forever. Okay, let's try the right end now. So on the right end, we're going to plug in 100. Okay. Let me do it just down here because I'm running out of space. So let's plug in 100 for f, or into f. So let's plug in 100. 6 minus 2 to the 100th power. 6 minus, let's see what 2 to the 100th power is. It's so big. It's 1, 2, 6, 7, 6, 5, 0, 6, and then a whole bunch of zeros. It's a huge number. It's so big it fills my screen. It's got 1, 2, 3, 4, 5, 6, 7. It's got 23 additional zeros. If I were to write all the zeros, I don't even have a big enough whiteboard right now. I'd have to go way off 23 more zeros. 23 more zeros past that. So you have 6 minus a huge number, which is a negative huge number, which we write as negative infinity. All right. It's never going to actually get to negative infinity. It's just going to be a very, very, very large negative number. Technically, if you want to be the life of the math party, that's a small number. But we, average people think of that as a large negative number. And so you would say, as x goes to infinity, f of x goes to negative infinity. So these are your two answers here. This is the left end behavior, and this is the right end behavior. Now, why would you want to know that, other than just to get the right answer on the test? I mean, if that's your only goal, to get the right answer on the test, well, then you can stop listening right now. But if you want to actually understand what this actually means, take out a little piece of graph paper or a graphing board. The left end is over here, negative infinity. The right end is over here. So on the right end, as x goes to positive infinity, x is going to the right, this graph is going down. So I already know that the y values are going down to negative infinity. However, on the left end, as x goes to negative infinity, y is not passing 6. So this is a ceiling. 1, 2, 3, 4, 5, 6. That's what we call a ceiling. So this graph would essentially, I'm not even really going to plot any points. I'm just going to kind of show you the shape. As you go towards negative infinity, as x goes towards negative infinity, this graph is going to approach its ceiling. It'll get closer and closer and closer and closer and closer. And then it'll get 5, 5.5, 5.8, 5.9, 5.99999. If I went off the screen here, it would just go like that, and it would get infinitesimally close to this dotted line, but it would never actually cross it. It would never even touch it. Yeah, and so that's what this 5.99 actually means. It means that you're very, very close to 6, but you're not actually equal to 6. So by determining the end behavior, you get a pretty good idea of what the graph looks like without having to do a lot of work. Yeah. I didn't plot the points very nicely. In hindsight now, I can see that there are some points on here that are not accurate, but I'm not trying to be accurate. I'm just trying to give you the idea. Okay. In the next example, I'll be accurate. A little bit more accurate. All right, let's try another one. Yeah. That's basically it for today. Just a couple loose ends before we move on to logarithms. We'll have another bundled section. 6.3 and 6.4 are bundled together. So just wanted to make sure I covered all of this before moving on. So example 2. Determine the end behavior. And then sketch the graph. Let me give you a function. So it's going to be f of x is 3e to the negative x plus 4. Okay, so let's do the left end. As x approaches negative infinity, what's happening to this function? I mean, if you already know, you have a really good sense of how functions behave, you played around with them over the last couple weeks or so, you probably can answer it right now. Yeah? You might already know what's going to happen. If you don't, well, then plug in a number and find out. Yeah? I recommend doing a little bit of both. You can make a prediction, but I wouldn't rest on that. I would actually figure it out. So plug in a quote-unquote large negative number. So plug in, say, negative 100. I wouldn't really go much farther than that unless you're using a computer. If you're using just a basic calculator, 100 is about all that the calculator will handle. In fact, some calculators won't even handle that. You have to use like 20 or something. It's not even very big, but negative 100. So go ahead and plug that in. F of negative 100 into this function. 3e to the negative. Now be careful, there's already a negative in the problem. So when you plug in a negative, it's going to be a double negative. And you're going to get 3e to the 100th. All right. Now if you get a really big number that blows up your screen, call that infinity. All right. If you get a really big negative number that blows up your screen, call that negative infinity. So let's see, e to the 100th, that's huge. Multiply it by 3, huge. It's a huge positive number. You want to see how big it is? It's 8, 0, 6, 4, 3, 5, 1, 4, 2, 5, followed by like 30 more zeros. It's actually more than 30. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 34 more zeros. I'm not going to write 34 zeros. Oh, and then you have to add 4 to that. Yeah. So you're going to get this giant number, 8064351425, a whole bunch of zeros, and then it's going to end in a 4. This number is huge. It's huge, and it's positive. So we call that positive infinity. Or you can just use the infinity symbol. You don't have to put the positive sign. Although if you do put the positive sign, it's not incorrect. It's still correct. Okay, so this is the left end behavior. Let's go to the right end. So as x goes to positive infinity, what's happening to f of x? Again, for the right end, use or plug in x equals 100. Yeah. Or plug in 1,000 or 1,000,000 or something. If you get an error message, then don't use such a big number. Use a little bit of a smaller number. So let's go ahead and do it. F of 100. I might need to erase some of this. Let's see. 3e to the negative 100 plus 4, which is 3 over e to the 100. I have to erase this. Okay, 3 divided by e to the 100. You kind of already know what's going to happen, right? It's going to be 3 divided by a huge number. We already know that, right? E to the 100, we already did it. E to the 100 was this huge number down here. Last time we multiplied by 3. This time we're dividing by 3. Or we're doing 3 divided by. This is a very, very small number. Yeah, it is a super duper small number. So small, it doesn't even show up on the calculator. It's all zeros. Yeah, it might end like in a 1 or something. It doesn't matter. It's a very, very small number. So if you take a teeny, tiny, teeny, itty bitty number and you add 4 to it, what do you get? You still get 4. Yeah. So the right end behavior is 4. you might be noticing a pattern. One of the two ends always approaches a number. You just never know which one it's going to be. Right? I mean, you could take a 50-50 chance and just guess, but sometimes it's the left side that approaches a number, and sometimes it's the right side. All right, so we got the end behaviors. That kind of gives us a rough idea of the graph. As you go to positive infinity, you get closer to 4. So you've got a ceiling at 4. That's actually a floor. I take that back. How do I know it's a floor instead of a ceiling? Because it's a little bit more than 4. It's 4.000000, so it's a tiny bit more than 4. So there's your 1, 2, 3 floor. Is that 4? That looks like a 9. It's right there, 4. Okay. As you go to infinity, this graph is going to get closer and closer to 4. As you go to negative infinity, this is going to blow up to positive infinity. So that's a rough idea of what the graph looks like. That does not count as my answer. It's just a rough idea of what's going on. Let's actually make a table and plot it. So I've got f of x is 3e to the negative x plus 4. Let's look at our mother table. Just use the base e. We saw this in the last video. 5 x's, negative 2, negative 1, 0, 1, and 2. I don't know if you remember the y's. You remember the y's? If not, we'll do them over again. So negative 2, and we're going to do e to the x to fill out these tables. All right, then we'll do the 4 and the 3 and the negative x all at the end after we finish this table. So negative 2, hit your E button. Oh, you remember that, right? It's 0.1353. Yeah, I always do at least 4 decimals. Negative 1, e to the negative 1 is 0.3679. This one you can do without a calculator. E to the 0 is just 1. E to the 1, you might actually memorize that one. That's 2.7183. And then e squared, 7.3891. Now the fun part, transformations. So let's do the negative first. We're going to multiply all the x's by negative 1. That's called a reflection. Right. Now you're going to multiply all the y's by 3. That's called a scalar. This is called a reflection. This is called a scalar. So reflections flip things over. Actually, it's going to flip it over this way. And the scalar is also known as a stretch. It's going to stretch it 3 times. Then finally, we're going to add 4 to all the y's. And now we're going through transformations. Let's do all the x's first, because those are just being multiplied by negative 1. So that flips. All the negative x's become positive, and all the positives become negative. That's going to flip the graph over the axis, over the y-axis. Now here's the more calculator-heavy part. You got to multiply and then add. I'm going to start down here at the bottom. 7.3891 times 3 plus 4, 26.1672. I probably won't graph that one. 2.7183 times 3, and then plus 4. Make sure you do it in the right order. You always multiply before you add. 12.1549. Here we can do this one in our head. That's just going to be 7. Yeah? 1 times 3 plus 4. That's 7. Remember, on the natural, the E graphs, you're only going to get one nice point. For the rest of the points, you just got to pick one that looks tolerable. So now I'm doing 0.3679 times 3, and then plus 4, 5.1037. And then finally 0.1353 times 3 plus 4, and you get 4.4059. You can kind of see a pattern. Look, 26, 12, 7, 5, 4.4. If I kept going, the next one would be 4.3, then 4.2, then 4.1, then 4.001, and 4.0000001. And that's how you get this floor here, where the graph is getting closer and closer and closer to 4. I only need to get a couple good points here. So let's go with 7. Yeah, 0, 7. Let's plot the asymptote at 4. Let's see if we can find one more decent point. How about this one right here? 5.1. So right about here. So that's 4, 5, 6. Let me label everything. There's 4, there's 5, there's 6, there's 7. So I need to go over 1 and up just a little bit more than 5. And there's your graph as I'd want to see it on the homework. Of course, this dot wouldn't really be that big. All right, that's good enough. If you can't get 5.1 to stick, or it won't mark it right, try this one. Try 4.4 would be right about here. Yeah, see, here's 4, and that's about 4.5. And again, if you use the graphing board, you could probably be a little bit more precise with the graphing board. Yeah, it would look something like our last graph. I'm not going to erase it and start over again. So, okay, so that's end behavior with graphing. Let's try another example. One thing you can do is you can draw the whole graph first and then just look at the graph to figure out the end behavior. That's actually the easier way to do it, because then you don't have to plug in so many numbers. Yeah? You can just graph the function and see what happens. All right, so example 3. Graph f of x equals negative e to the negative e to the x minus 1, and then plus 2. Then determine the end behavior. So I'm reversing the order of operations here. I'm going to draw the whole graph first. This time I will use my board. I'll try to be a little bit nicer with my points. Put that off to the side. We'll come back to it. All right, use the base. So this is base E, mother function. So we have y equals e to the x. I should have just kept that out. Comes in very handy to have that ready to go in all your E graphs. When you're doing your homework, you can make one of these tables and then use it for every graph that involves E. Saves you a lot of time. I erased mine. I got to start all over again. So let's see. E squared, 7.3. I'm just going to do 2 decimals on this one. The graphs are not that precise anyway, so 2.71, 1, 0.37, and 0.14. You could be more precise. I think this one was like 0.13, what was it, 1353 or something. It doesn't really matter. I mean, we're using a graphing board that's not very accurate. So as long as you're close, it has a pretty good tolerance for not being exact on this. All right, we have lots of stuff going on here. We have a reflector. This reflector is in front of the base. So that means to multiply the y's. You might want to make a note of that. If the reflector is in front of the letter x, well, then you multiply the x's. If the reflector is in front of the base, then you multiply the y's. Okay. Then you're going to add 2 to all of the y's. That's going to shift up. The negative is going to reflect. And then this negative is x minus 1. Going back to chapter 3, that one's opposite. So don't minus 1, plus 1. You do the opposite of negative 1. The opposite of negative 1 is positive 1. All right. That's tricky if you a little rusty since we finished chapter 3. You might be going, chapter what? You know, chapter 3 seems like it was an entire pandemic ago. All right. Let's go down the list here. So I like to do all my x's. So 1 plus negative 2, that's negative 1. That's 0, that's 1, that's 2, and that's 3. The y's might require a little calculation. So negative 1 times 0.14 plus 2, 1.86. 0.37 times negative 1 plus 2, 1.63. All right. Negative 1 times 1 plus 2, that's 1. 2.71. Although if I round it, it's actually 2.72. But again, as long as it's close. Times negative 1 plus 2, negative 0.71. And then finally, this one probably won't, well, I don't know, I might be able to fit it. 7.39 times negative 1, and then plus 2, negative 5.39. I can fit it. I'll make them all fit. So now these are the ones we're going to graph. There's my y. There's my x. Let's see. Let's put the asymptote first, called the HA. Whatever the vertical shift is, that's your asymptote. very important on your homework that you graph that first. That's the ceiling. Notice all of these values are below, all the y's are below 2. Yeah. 1.86, if you were to keep going, you'd get 1.9 and 1.95 and 1.955 and 1.999, and they would all be less than 2. So everybody is below 2. And now let's just plot as many as we can. Let's see. We definitely can do that one. 1, 1. Yeah, that one's pretty good. I'm actually going to try to show them all. Let's see. -1 and 1.86. So just very close to 2. 0 and 1.63, so right about there, just a little bit above 1. 2 and -0.7, so again, it's very difficult to see. It's right about there. And then 3 and 1, 2, 3, 4, 5. There's -5, there's -6, so right about here. There's your graph. This is probably going to be my last. This is my last example for this section. It's just to cover up a few loose ends. At the very end of the homework, you might run into these problems. So I'm going to go ahead and do the rest of the, or answer the rest of the questions about this graph. What other types of questions do I like to ask? Well, I'll give you a free one. Domain. Just before we put this to rest, domain is all real numbers, negative infinity to infinity. Range, look at the graph. Everybody is below 2, so negative infinity to 2, but not touching 2. 2 is open. And then the end behavior, just look at the graph. Look at the left arrow. As x goes to negative infinity, what's happening to y? Or f of x? It's getting close to 2. Yeah, it's getting very close to 2. As x goes to positive infinity, so that's the right arrow, looking on this side, what's happening to y? Clearly, you can see by the picture, y is going down to negative infinity. So these are the questions that I often ask. What's the domain? What's the range? What's the end behavior? What's the horizontal asymptote? I ran out of room. This is the horizontal asymptote. Here, I'll write it a little bit bigger. All right, that pretty much does it. If you have any other questions, individual problems that you're stuck on, check Canvas, go to the Zoom link. I'm in my office every day, or I'm here in my kitchen every day at 12 o'clock to answer your questions. So Dr. Jordan signing out. Take care.